Okay. Okay, so I will start to share the screen. So do you already go through the notes previously? Because I have uploaded it a week ago. So I believe that maybe some of you already went through the notes. Okay, so if you have any questions, so you can directly unmute your microphone and you can ask any question. Okay, so like I already mentioned, last class we already discussed a little bit on we call it as all the introduction, or I have introduced to all of you some of the separation technique that we are going to learn throughout this course. Okay, so for today for today lecture, so will be more focusing toward the distillation, because I believe that even though distillation is very conventional, so I mean that since we are in I think secondary school, we already have been exposed to this kind of the method, but for in the syllabus, I want to explain, give we call it as a thorough discussion in terms of how we can differentiate between several distillation method. Okay. So for the learning outcome, of course, towards the end, so at least you know what is the theory of the distillation, of course, and then type of distillation, because in this syllabus, we are going to learn some of the distillation technique. So maybe the one that you have conducted in the lab, or maybe in your working area. So for example, in the industrial application and so on. Okay, so other than that, of course, about the application. So when we talk about the application, at least you're supposed to know, for example, each of the distillation method, so it will be contribute at least to one application. Okay, so when we talk about the distillation, so basically the first have been introduced to increase the alcoholic content. When we talk about this one, so usually, for example, in the lab, so we have several type of the alcohol in the mixture, right? And then we want to separate it based on different type of the alcohol. So maybe distillation is the best method that we can choose. For example, why? Because due to the boiling point. So like I already explained, in the introduction of the separation technique, so we have several characteristics to determine which separation technique that we can use. For example, based on the particle size, right? Based on the density, right? And then when we talk about the distillation, so it will be contributing to the boiling point, right? So that means when you are having some situation, you are having some substance that have, for example, quite significant in terms of the boiling point. So I think the distillation method is the best separation method that we can use. Okay, other than that, so I believe that this is quite popular, widely used. We talk about the crude oil, for example, in the crude oil, right? So there are many products that can come from the crude oil, right? So even currently, we are using many things that come from the crude oil. So in another word, when we talk about the crude oil as a sample, so how we can get each of the products separated. So I think distillation is the best method that we can use. Okay, so this is for example, in the oil and gas industry application. So of course, for the pharmaceutical and so on. Okay, so when we talk about the distillation, so it will involve several calculation, but in this syllabus, we didn't focus more on the calculation. So it's more towards the theory, and then the basic principle about the apparatus and so on. Why? Because usually when we talk about the distillation, so this is very important to know about the, for example, mole fraction. So how much, right? The fraction or the mole of the liquid, for example, will be converted, for example. And then from that, we can calculate the distillation efficiency, okay? When we talk about the distillation efficiency, because when we talk about the separation itself, it talk about the purification. So, for example, how much we can purify the liquid from the solution, for example, the mixture, right? So it will be having certain calculation involved. Okay, so these are the example. For example, as we can see here, we call it as a crude oil refining. So distillation tower. So when we talk about the distillation tower, so I believe that you know about this one, but maybe the basic principle, for example, because we have many types of the distillation. So Is it referring to the simple distillation, or is it applying the fractional distillation, for example? So today we are going through in detail all the types of the distillation. Okay. So as we can see here, this is very important, as we call it as a brief introduction to know why we need to use distillation instead of any other technique, right? Because we have several separation techniques, right? Okay, so the most importantly, the one that I already explained, for example, you have the liquids or the substance, they are having several boiling points, okay, and then you want to separate it to get, for example, you want to separate the yellow solution from the mixture of combination between these three. Okay, so you have to look at the boiling point. So usually the most lowest boiling point, right? So it easily to be vaporized, right? Okay, so I think that at least you have an idea when we talk about the boiling point of the solution. So the best method that we can use is a distillation. Okay, so I think that when we talk about the distillation, so it involves two important process happening. The first one, we call it as evaporation and also condensation. So what does it mean? So I hope that you still remember. So I will try to imagine that you are in the lab, for example. So you have a simple distillation setup. So of course we have a flask, right? You have to connect it with the thermometer. So it will be connected to the condenser and so on. So we can predict that there will be two major process happening. Okay, when we talk about the vaporization, so you know that from the liquid, so it will be converting into the gas, or we call it as a vapor liquid, right? And then it from the gas, so it's possible for this gas, right, to go back again to the liquid. So the last product that we can collect is the liquid. So this is distillation. So it involving the vaporization and also condensation. Okay, so because when we talk about the separation technique, of course we have evaporation. So when we talk about the evaporation, so for example, you have a salt solution, right? You want to collect the salt. Okay, so you can just leave the salt solution, okay, under the sun, for example, still you can get the salt powder, for example, okay, because the solution is already vaporized and then forming a gas. Okay, so but how we can collect back the gas? So distillation is the best method because it will condense back from the gases to the liquid. Okay, so at the equilibrium, so it means that when we try to set up the temperature, right? When we try to set up the simple distillation, for example, and then we introduce the temperature to the solution, so it will be undergoing equilibrium between liquid and also gases, or we call it as a vapor in this case, right? Okay, so as we can see here, so this is the explanation from this kind of point. So from this figure, we know that, so it formed from the liquid go to the vapor and vapor going back to the liquids, or we call it as this one is a vaporization. This one is a condensation, right? Okay, so usually when the lower temperature, so that means, for example, you have a substance A in the mixture. So you know that the boiling point of the substance A is much more lower as compared to the substance B or liquid B. Okay, so you assume that after it's achieved or it reach its boiling point, so of course it will be converted into the gases or vapor liquid, right? Okay, so of course when it start to heat, so it will be producing some vapor, and then once usually it arrive the equilibrium, so basically we call it as the amount of the vapor will be much more as compared to the liquid. Okay, so this is the difference between distillation with another separation technique. Okay, so as we can see here, when we talk about the cyclohexane and toluene, of course, they are having different in terms of the boiling point. So cyclohexane have much more lower boiling point as compared to the toluene. So we are expecting, for example, when it reach the 81 degrees Celsius, most of the cyclohexane will be forming, right, of the vapor, and then the toluene will remain as a liquid because it's not reach yet the boiling point. So from that we can collect, right, the one that from the collector, so is the cyclohexane, and then the one that remained in the flask originally is a toluene. Okay. So I think that it's quite similar. So this is the one that we already talked a few minutes ago where we talk about the distillation. So it is a very important organic process because it's involving organic compound, organic molecule, okay, to separate two or more. So it can be more. For example, in the crude oil, the one that I gave example previously, we can separate many hydrocarbons in the crude oil. So there are many, it's more than 5 hydrocarbon that we can collect from, we can separate from the crude oil, right? Okay, having boiling point from a liquid mixture. So the most importantly is we know what is the boiling point. But if we didn't know what is the boiling point of the certain substance, still we can go for the distillation because in the setup itself, we have a thermometer. Once we get the vapor inside the, for example, the flask, and then you can see from the condenser. So from that, you can see from the thermometer. So what is the temperature? It start to forming a vapor because it's already achieved the boiling point. Okay, so other than that, when we talk about the distillation, because we have so many type of the distillation, and maybe some of them focusing on the separation, but maybe some of them based on the purification. We want to purify it. Okay, and then maybe other than that, we want to separate it from the bulky solvent, for example, the one that we usually in the lab, use in the lab, for example, rotary evaporation, right? One of the setup for the distillation. Okay, so this is quite similar. So of course, it's supposed to have a different in terms of the boiling point. Okay, so the process will be undergoing separation and purification. And the most importantly, what is the cycle happen in the system, which is we call it as the evaporation or vaporization and also condensation. So this is the most important one that I believe that you should know at least the basic principle where we talk about the distillation. Okay, so do you have any question? So I hope that all of you are here. If you have any question, you can just unmute your microphone or you can just write in the chat. Okay, so I will read and try to answer it. Okay, so this is quite similar to the one that we already explained. Okay, so of course the aim of the distillation, so we want to purify. Sometimes we can determine the boiling point of the substance. Okay, so separation of liquid organic substance from each other from a non-volatile solid compound. So the best example that we can give here is example of the purification of salt water, right? When you have a salt water, you know that the salt will be dissolved in the water, okay? And then when you set up you put the salt water in the flask, okay? You put the connector, so you have a thermometer, and then it will be connected to the condenser, for example, and then you collect back, right? So at the end of the process, so you are expecting the pure water will be here, right? Because when it's achieved 100 degrees Celsius, boiling point of the water, and then the salt will remain here because the boiling point of the salt will be much more higher as compared to the water. Okay. Okay, so of course distillation depend the most important one in the boiling points. Okay, other than that, maybe the size of the sample or internet. My internet connection is currently is a very heavy running at my home, so I'm very sorry if sometimes the lecture will be lagging. Okay. Okay, so you can just write in the chat so that I can repeat any point that I miss. Okay. And the last one is depending on the distillation apparatus. Of course, when we talk about the distillation apparatus, it will be represent what type of the distillation that you are using. Okay. Okay, so are you familiar with this one? So the answer is yes, right? So when we talk about this one, so this is where we put the sample, or we call it as the mixture. So homogeneous mixture basically. Because when we talk about the separation of the liquid in the liquid mixture, so usually it has to be homogenized. Okay. And then you have a thermometer. So usually when for the mixture, we cannot put more than 2/3. Okay, so it cannot be too full because we leave the space to make sure that the vapor have their own space, okay, to escape from the liquid, right? And then for the thermometer also, we didn't put a too higher or too below and then until reach in the solution. Why? Because usually the purpose of the thermometer is to measure the vapor happen. Okay, because you know that this vapor, we call it as a, we can calculate the vapor pressure, right? So this vapor, for example, forming, so we can determine the temperature, the boiling point. Okay, so you have the adapter or the connector. So from here to here, we call it as a condenser. Okay, so the condenser is designed, okay, to have, for example, here, the one that we call it as a water in. So water in means the cool water, so that when you start the distillation, the cool water will be going into the condenser. Why? The purpose is because we want to convert back the vapor or the gas into the liquid, right? Okay, so this is the one that we call it as a water out. Okay, so I still remember when I'm doing the degree, right? So set up the distillation is quite challenging. Sometimes we become very confusing, so where we have we need to plug in all the wires and so on, right? Because when we have a mistake in doing this kind of the setup, so the distillation process cannot be completed, right? Okay, so from here we can collect we call it as a distillate. Okay, the one that we collect in the receiving flask is a distillate. Okay, so usually when we start the distillation, first 2 to 3 ml, right? We try to throw it first because we want to make sure that the one that we get is the really pure from the solution. Okay, so when we talk about how it works, so I didn't go through in detail one by one because I believe that from the figure, okay, this one, like I already mentioned, for example, if you have the liquid, and then you start the heat, okay, sometimes we try to avoid using direct heat like this, right? We put into the under the magnetic stirrer, and then we try to put the flask into the oil bath, for example, to make sure that no overheating happen, or we call it also that is same. So Hazia said that is it same with the rotary evaporator? Yes, Hazia, yes. But when we talk about the distillation, so we have many type of the distillation. So rotary evaporator is under the vacuum distillation. So I will try to discuss after this one by one. But yes, rotary evaporator is one of the example that widely used in the lab, right? Okay. Okay, so when we talk about the liquid, so it will be going here, right? And then we can determine the temperature, right? And then it will be having a condensation process. Okay, and then we collect the distillate. Okay, so this slide explain the one what happened, how the process is undergoing. Okay, another important thing that I want to highlight when we talk about the mixture, like we mentioned, for example, you have liquid A and also B, or you have a toluene, right? Okay, and also the one that previously, for example, you have toluene and also cyclohexane. So you know that the difference between these two we call it as a mixture is quite significant, which is more than 20 degrees. So of course, one of them you can use a simple distillation. Okay, for example, when you are having this kind of toluene and also cyclohexane, okay, so the one that have the lower boiling point, so will be undergoing the distillation, we call it as a vaporization. So in another word, the substance that have a lower boiling point, so it easily to vaporize. Okay, so the one that will be coming out in the receiver is the one that easy to vaporize. The one that remain is substance that very difficult to vaporize because it has much more higher in terms of the boiling point. Okay. Okay, so this is one of the examples. So for example here, you have the solution salt water, homogeneous salt water, and with the combination of sand. For example, you go for the sampling and so on. So it's possible for you just want to collect the salt water, but it will be including with the salt. Okay, so you have to think how you can separate or purify the compound, right, to get the pure water. So of course, the first this separation technique that you can use is because the sand is more dense as compared to the salt water. So you can see with your naked eyes clearly, okay, the separation happened. Okay, so of course you can use a filtration. So like I already discussed previously where we talk about the physical characteristic when it has more in terms of the density, more dense as compared to the others. So you can use a filtration. So from that, okay, so you can proceed to separate the water with from the salt, okay, by using a distillation. Okay, so I think that this is the best example. For example, I think in the final exam, the question is something to try to give you the situation, for example, and then you have to suggest not only one of the separation technique that you can use. So based on the explanation, you're supposed to know, for example, you choose a distillation. Why? Because, for example, due to the boiling point and so on, when you try to choose a filtration, so you have to give the reason, for example. Okay. Okay, so this is the one that we already discussed. I think that the slide, even though we have many slides, but sometimes it keep repeating, redundant. But the most importantly, the principle is quite similar. Okay, so this is the one when you try to go through in details. But the most importantly, the setup of this distillation here. So this one we call it as a simple distillation, right? The one that we always do in the lab. So this is simple distillation. Because after this, I will introduce a little bit what is simple distillation as compared to the others. Okay. Okay, so of course, when we talk about the distillation or any separation technique that we apply, so usually no chemical change happen into the substance, right? Okay. Okay, so when we talk about the calculation, so like I already mentioned, so even though, for example, in the application, real application in the industry, for example, or the chemical engineering student always exposed to how to calculate all the separation process happen, right? Okay, but as for the chemist, we want to know more about the basic principle in chemistry behind the distillation itself, right? But the most important one that I want to introduce, of course, one law. So this law, we call it as a Raoult's law. Okay, so basically, what is the purpose of this law? So is it important to have this law? Okay, so when we talk about the Raoult's law, so Raoult's law is equal to this one. Okay, so you have, for example, the we call it as a partial pressure. For example, A is substance A is equal to mole fraction of substance A, and then you have to multiply by the P naught is a vapor pressure. Okay, so I think that you're supposed to know this one, okay, as a theory. Okay, why? Because from that you can calculate the mole fraction. So of course, towards the end of the distillation, usually we want to know how much the we call it as the compound can be separated from the mixture. So the answer is you can get it from the fraction of the mole fraction. For example, you have A and also B, right? Okay, towards the end of the distillation, maybe you can get 90% mole fraction of A and then 10% in the mole fraction of substance B. So you know that they still have some mole fraction of B inside your distillate. Okay, so this is not, for example, not 100%, we call it as a pure, okay? But it's approaching the purity of the substance A, right? Because we can do 90% instead of, for example, you have less than that. Okay, so other than that, the most importantly from this equation, so the one that which is here, okay, vapor pressure, where the vapor pressure come when we talk about the distillation. So for example, you have a solution, right? So the solution is in the liquid. Once it reach its boiling point, the one that I already explained. Okay, so the molecule of the liquid try to escape, right, from the mixture. Okay, and then it will be forming a vapor. Okay, but you know that when we talk about the distillation, the process happen in a closed system. Okay, so the molecule of the vapor so keep collide. with the surface of the flask, for example, from that it will be producing a vapor pressure. So this is the meaning of the vapor pressure. Why vapor pressure is important? Because when it achieves the equilibrium, from that, so it will be similar to the boiling point, the one that I already mentioned previously. We can determine the temperature. From that, we can predict the boiling point of the substance. Okay, so I think this is the basic theory in terms of the law. Okay, to calculate, for example, the mole fraction, to know what is the boiling point of the substance. Okay, so this is just one of the examples. So I think you can go through on your own. Okay, so just a simple calculation related to the law. Okay, so before I proceed to discuss a little bit detail on each of the distillation process, so do you have any question?
No, Doctor.
No, okay, I think because this is the revision, I can say that just because all of us already know about this one, just do some revision related to this topic, okay? So I give the lecture to make sure that you remember back, okay, all the type in term of the distillation. Okay, so we go for the simple distillation. The most importantly, why we need to introduce to all of you in term of different type of the distillation. Because when you are having some mixture, for example, you know that it have a different in term of the boiling point, but which distillation is more fitted to do the separation, right? So it must be a reason to have different type of the distillation. Okay, so I think for the simple distillation, so I can go through quite faster because simple distillation is the one that I already explained previously. Okay, so in terms of the apparatus, for example, so at least you know the flask, the condenser, and then the receiver. So this is the three main apparatus where we talk about the distillation. Okay. So this is the example and so on. For example, in this example, we want to separate the acetone and water, right? Because acetone have much more lower boiling point, I think 60 something as compared to the water, 100 degrees. So of course, acetone will vaporize or volatile first. So that's why the one that we collected is acetone, and the one that remain in the flask is a water, right? Okay, so the most importantly, why we need to use simple distillation, right? Before we go through in detail what is fractional distillation, what is vacuum distillation, what is steam distillation. So this simple distillation, so usually we use it when you have a solution or liquid in the mixture that have different boiling points. So at least 25 degrees Celsius in terms of the differences. So at least. So usually sometimes currently they are approaching, for example, if you have 50 degrees Celsius in terms of the difference in terms of the boiling point. So this is the most, we call it as the best one. So if you have two type of the liquid substance, right? And then you know that one of them, for example, 78 degrees Celsius and another one is 100, for example. So you can see the difference between these two boiling points is almost 30 degrees. So simple distillation can be the one that you can choose. Okay. So the meaning of simple distillation, for example, you have two liquids and then it has should at least difference, which is 25 degrees Celsius. Okay. So another important information when we talk about simple distillation involves a single equilibration between liquid and vapor. So this is the one that we already discussed, right? So we have a liquid and then it will be forming a vapor. Okay. This distillation is referred to involving one theoretical plate. So usually when we talk about the distillation, sometimes we always look at the theoretical plate. So what does it mean, right? So theoretical plate, so the symbol of the theoretical plate in the distillation is a small n. Okay, small n means it represent the cycle that happen in the distillation. What kind of the cycle? Cycle involving the vaporization and also condensation. Okay, so because the equilibration between these two processes from the liquid to the vapor and then it will be forming back the liquid. So one cycle, one process here, we call it as a one theoretical plate. In another word, when we talk about the simple distillation is equal to one theoretical plate because only one process, one run process of the equilibration happen. Okay. Okay, so there are several examples, so you can go through on your own. Of course, you can get from another sources too when you try to search, for example, simple distillation for acetone and water. So from that, you can have a clear idea. Okay. So at least you're supposed to know, for example, this kind of the process. When you are having this kind of the process, so you're supposed to know why. For example, acetone will vaporize first, for example, right? And then why water remain in the flask. So you can give the justification based on that part. Okay, so if you have time, of course, you can go through. So sometimes I put some animation video. So I believe that because we are still quite interesting, right? If we are having some kind of the video, so even though we didn't have time to go through in the lecture, so of course you can just click it when you are having free time to see more about the distillation. Okay, so this is the one that very widely used. Okay, even though in the undergraduate study, okay, even though some of the we call it as a master program, when we try to introduce the simple distillation, this is the best example that we can use. Okay. Okay, so when we talk about this one, from that you know that this is our aim is to purify the ethanol. So you know that you have the ethanol in the water, right, in the solution. Okay, and then you start the distillation and so on. This is for the simple distillation. Okay, so I think before we go through to the fractional distillation, maybe we can try to answer the question together here. Okay, you can just unmute your microphone to answer the question. Okay, so the first one is why is it necessary to add a boiling chip to the round flask? This is quite simple. So usually when you put, we have a flask, we put our mixture, right? So usually we try to put 2 or 3 pieces of the boiling chip. So this is the one that I still remember when I'm doing the undergraduate study, right? The lab staff always, we call it as reminding us to put this one. So is it necessary to have these boiling chips to the round bottle flask, to the mixture? What do you think? What happened if we didn't have this boiling chip into the mixture? Is it the distillation process can proceed or not?
It still can proceed, but the bumping of the liquid will occur.
Okay. Yes, that correct, right? So we want to avoid the bumping of the liquid because sometimes direct heat from the heater. Okay, so this is the one that I already mentioned. Okay, so why we need to discard the first few milliliter to distill it So because this is just the first run or another word we want to condition the distillation apparatus first, and then from that after we discard a few milliliters, so we can proceed with the real collection in the flask, right? Okay, so what is the purpose of the condenser? So this is very simple, but if you have you want to volunteer to talk, so you can give the answer. So what is the purpose of the condenser? So why the condenser is located, for example, somewhere important in the distillation? Do you have any idea? Yes,
The
Omar?
purpose to allow to high pressure and high temperature refrigerant vapor to condense and ejectate.
Okay, so thank you so much. Yes, right? Because we put the condenser, usually we connect it to the water, right? So we allow the cooling process basically happen in the condenser, right? Because we want to convert the vapor to the liquid back. Okay? Okay, so if you have 3 types of the alcohol, for example, ethanol, methanol, and propanol, is the simple distillation. distillation is the best method to separate them. So for this kind of the question, so usually you supposed to know what is the boiling point, of course, for each of the substance. If they are having the one that can fit with a simple distillation, so okay, you can use a simple distillation. Other than that, so usually where the fractional distillation come when the difference between the substance is very small. So for example, you have 50, right? 50 in terms of the difference between the substance A with the substance B, so you can use simple distillation. But if you are having the we call it as a difference in terms of the boiling point between the solution is quite low, okay, so fractional distillation is the best method that you can use. Okay, so I think I can proceed directly to the fractional distillation to discuss about this one so that you can make a comparison with simple distillation, okay? Okay, so from the, as we can see here, from the figure, okay, so can you see any difference in as compared to simple distillation with the fractional? So what are the difference? I think it's quite clear, right? Okay, so when we talk about the fractional distillation, so we have everything quite similar to the simple distillation, but the most importantly, we call it as a fractional column, right? So this is very important. Okay, so why name is fractional distillation? Because it has a fractional column. Okay, so as we can see here, the fractional column, okay, this is the one that we can, I think that quite widely used in the lab, right? So usually we have the fractional column and then we try to fit the fractional column with some substance or material. Okay, from this figure, even though this is just a drawing, so you can see something like the bead, right? Okay, so when we talk about the substance in the fractional column, so the most widely used, we call it as a glass bead, eh? Okay, so it packing quite packed in a column. Okay, and then another one we have sometimes a copper, copper metal that we can fit in the column. So this one is usually in insulator, so we cannot allow any conduction, for example, conductor to be fit in the column, right? Okay, so basically, what is the purpose of the fractional column? So do you have any idea before we discuss further? Why this fractional column is important in the fractional distillation? Do you have any idea before we discuss in details?
Maybe to
Answer Maya?
differentiate the temperature. Let's say low temperature, they will drop again. Then to separate the temperature. To
Okay.
separate.
Okay, so that means, yes, that's correct. So for example, you have different type of the boiling point. So the one that have a higher boiling point, so it will remain, right? So usually it will retain at the bottom and then going back into the solution, right? Okay, so this is the most important one, okay? So when we talk about the why, what is fractional distillation and then how it works basically, right? Okay, so fractional distillation is a technique employed for many complex liquid mixture. For example, mixture with component that have closer boiling point. So it will be different with the simple tadi. Okay, when we talk about the simple is, for example, is significant in term of the difference. But when you are having very complicated mixture that are having quite similar boiling point to each other, so the best distillation method that you can use to separate them is a fractional distillation, okay? Okay, so for example here, in a fractional distillation, a mixture of liquid is boiled, of course. Okay, try to assume that it will be boiling because due to we introduce the heat and the resulting vapor travel up to the glass tube called fractional column and separate. Okay, so it will go, for example, from the mixture and then we connect it to the fractional column, right? So it will be undergoing here, okay, to do the process similar to the simple distillation, which is only two process happen in distillation, vaporization, and also this condensation, right? Okay, but when we talk about the fractional distillation, it lead to better separation. So why? Than the simple distillation? Because the glass bed in the fractional column provided theoretical plates. Okay, so you know that the one that I already mentioned, theoretical plate, for example, is N, small n, on which the vapor can condense and then re-evaporate and recondenser. Okay, so I hope that you understand. For example, I take one example. For example, you have substance A and also B. Okay, so this is a simple distillation. So you go, so this is, you put the solution in the flask, for example. Okay, the mole fraction substance A, for example, 50%, for example, section 50% substance A or liquid A and 50% liquid B. So you know that they are having quite close in terms of the boiling point. Okay, so it will be undergoing the, for example, the evaporation, right? Okay, and then it will be condensed and then you can collect the distillate, right? Okay, so towards the end, so you find out that 68% of substance A and then another 32% is for the substance A. Okay, so you know that you believe that the boiling point of the substance A is much more lower, so that's why it will be vaporized, right? Okay, so this is, we call it as, for example, this is a simple distillation and it involving one cycle, which is, we call it as a one theoretical plate, which is vaporization and also condensation. Okay, so of course, you can proceed with another simple distillation. For example, you take 86% here, and then you do the second set of the simple distillation. Okay, so this is theoretical plate is equal to 1, okay, and theoretical plate is equal to another 1. So you can keep, okay, doing the simple distillation, for example, until the substance A achieve more than 90% in terms of the mole fraction. Okay, so this is for the simple distillation. So that means you have to keep doing it many times, okay, to get the most pure one, because simple distillation is one run process, okay? But when we talk about the fractional distillation, so it has a better separation because in the fractional column, okay, so the cycle keep undergoing. So that means you can have the theoretical plate N is equal to, for example, 3. So I think that you understand when we talk about the N is equal to 3. So the process of the vaporization, condensation happen 3 times in the column, okay? So that the one that you collected towards the end usually is the pure one. So this is the better, we call it as a why we choose the fractional distillation sometimes for the purification process, all right, for the purification purposes, okay, because one theoretical plate is equal to one simple distillation. So for example, you have theoretical plate is equal to 3, so you know that 3 cycle happen in the column is equal to 3 simple distillation. So in another word, instead of you are doing 3 times of the simple distillation, why not you are using directly fractional distillation, right? So this is the meaning of the why better separation we can get directly from the fractional distillation. Okay, so as we can see here, so this is where that's why the word say that it's evaporation happen and then condensation and then it can evaporate and then it can be recondensed. Why? Because when the lower boiling point go into the column, so because it has low boiling point, so usually it will be forming a vapor. Okay, and then the one that have high boiling point, so usually it has to go back into the liquid and then the process keep running, doing, okay? So the more volatile liquid will gradually move towards the top on the fractional column, okay? Higher boiling liquid will stay at the bottom, giving a better separation. So we are expecting that at the bottom of the fractional column, the one that has higher boiling point, the one that at the top of the column, which is the one that ready to condense to forming back the liquid, right? Okay, so this is a lower boiling point. Okay, so you can have a assumption or expectation on that. Okay, so this is the one that I already explained. So this is we call it as the one from the book lah. Okay, so I think that you can summarize from the one that I already explained, quite similar with this one. Okay, so this is the meaning of the cycle, the one that I talk about, which is referring to the theoretical plate. Okay. Okay, so I think same goes to here. Okay, the word of vaporization condensation cycle. So that means one set of the equilibration happen in the distillation. Okay, so this is in fractional column. So the column is packed with the copper sponge, or another one, the one that I already explained is a glass bead, right? Okay, so the function is to cool, to have a cooling process happen in the fractional. So that when the cooling process happens, so that's why it will go into the step, several step, which is keep repeating the cycle. Okay. So a measure efficiency of the column is known as the number of theoretical plates. So of course we can calculate it. Okay, there will be a calculation involving to calculate the theoretical plate. And then in but when we talk about if it having two theoretical plates, so you know that two cycle of the vaporization condensation happen in the column. Okay, so for example, if you have the theoretical plate is equal to 3, okay, so it will be equal to the 3 simple distillation. So you have to do 3 times of the simple distillation when you are having 3 theoretical plate for the fractional distillation. So in other words, fractional distillation will be more rapid, okay, more rapid, and then it's not time consuming lah, okay. Okay, so when we talk about this one, for example, this is where we talk about the simple distillation. So based on the graph also, we can predict. For example, you have the 20% of the cyclohexane and 80% of the toluene. So you know that this is 80%. So you can drag, okay, to the liquid because at the bottom is a liquid, at the top is a vapor. Okay, so from that, okay, so you can just go through the graph, okay, at the vapor side, at the vapor region, and then you can going back, so you can see that the answer is 50%. So what does it mean? For example, if you have a simple distillation, okay, at first you have 80%, and then after you try to purify or separate it, okay, so toluene will be having 50% and another 50% is go to the cyclohexane. So what you need to do? So you have to repeat, or we call it as it's not repeat, I mean do another type of the simple distillation, right? To get the pure substance, okay? So if you can go through on your own about the graph of the fractional distillation, so you can see that the graph keep increasing when we talk about the cycle or the theoretical plate. Okay, so I think that we already discussed much further in detail about the distillation, fractional distillation. So at least we have an idea what are the difference, right? In terms of the boiling point, for example, so you can know that the closer boiling point, okay, so you should use a fractional distillation. In terms of the apparatus, fractional distillation use a complex apparatus. Why? Because we add one more, which is a column, right? When we talk about the repetition, simple distillation is one run process because only one run process of the vaporization and condensation. But when we talk about the fractional distillation in the column, so the theoretical plate can be more than one. So it keep repeating the cycle, right? So that the one that we collected is the pure substance, right? Okay, so this is, for example, you talk about the separation of the solvent from the solute. We try to assume the solute, which is from the solid form, for example. So usually simple distillation is the best method as compared to the fractional distillation. For example, you want to separate the salt from the water, right? So usually we try to use the simple distillation, okay? Because in terms of the boiling point. Okay, so that's why when we talk about the uses, fractional distillation is very widely used in the crude oil refining or the crude oil separation of the crude oil. Okay, so we go through a little bit. What does it mean by the separation of the crude oil? Basically, when we have a sample, or in industry, we call it as a feed, right? Okay, so we have a crude oil. So why fractional distillation is the best method that we can use? Because the purpose of the separating the crude oil, because we want to separate the several hydrocarbon. So several hydrocarbon, for example, you have methane, okay, you have propane, right? You have ethane. So all of them have quite similar in terms of the boiling point, right? So that's why we are using fractional distillation, so that we can separate it to get products that are very useful. Okay, so this is an example. So you can see the animation. Okay, so the crude oil having many hydrocarbons, and as you can see from this animation, the one that have the low chain, so the low, we call it as a shorter alkyl chain, because it have low boiling point, so that's why it will vaporize first. It will be going at the top of the column. But the one that have longer in term of the chain, so because it has more higher in term of the boiling points, very difficult to vaporize, so it will remain right at the bottom of the column. So as we can see here, this is boiling point quite high, and then the one that have a low boiling point, so usually it will be at the top. Okay. So when we are using the fractional distillation, so this is the best method that we can use, right? Okay, so for example here, this is an example of the crude oil. So it look like a tower. So because each of the stages here, we have a tray, tray that can separate it. So we can collect each of the product. Okay, so the product is, for example here, something like this lah. Each of the tray, or we call it as a the one that have a higher boiling point will remain right at the bottom. The one that have the lower boiling point, so usually it will be going at the top. So as we can see here, small molecules mean the one that have a shorter chain, so it has a low boiling point. So it's easy to volatile, right? As compared to the one that have a large molecule or longer chain. So it has a higher boiling point and not very volatile. So I'm sorry, there are many bell keep ringing towards the time for the buka puasa ni, because there are many, my neighbor are very kind. They always give us food. Okay. So as we can see here, there's the example. So these are the application that we can use. I think that very applicable, right? Even though currently. Okay, so I think about that's all for the fractional distillation. Okay, from your opinion, what are the advantages of using fractional distillation? Because we only learned about the simple distillation previously. If we can compare, what are the difference instead of using simple distillation with the fractional distillation? Do you have any idea? I open to, yes, Ida, you?
We can separate the quite similar of the boiling point of the substance, the solvent.
Okay, that's correct, right? So we can save the time, kan? It's more rapid. Okay, and then of course, it's very advantage if we separate, if we have the mixture that have similar boiling point, like Ida you said. Okay, so we always talk about the advantages. Another advantages, the one that I want to highlight is when we talk about the fractional distillation. So it always referring to the purification. So it's quite important because it can purify more in much more shorter time. Okay, so how about the disadvantages? So of course it has the disadvantages too, right? What do you think? Yes, Omer.
In terms of
Oh, yes.
apparatus, I
Very
think
expensive.
Okay. So Zawahir, you want to go first? Okay, maybe.
I think in terms of actual equipment is more bulky for the fractional compared to the simple. Yeah.
Okay, that's correct. How about Omer? What's your opinion on this one?
I think it can be expensive, more expensive.
More expensive, right?
Also, I think with this a lot of hazards.
Okay, yes, that's correct, right? So Zawahir said that it's more bulky. So when it's more bulky, more complicated, more complex, so of course it will be more costly. Okay, more energy needed lah. Okay. So that's the most
Also, I
important.
think yeah, it causes a lot of environmental pollution
Why do you think in terms of the pollution? Why, Omer?
because
Mm.
in my city,
Mm.
I see like this tower. This causes a lot of pollution. Uh,
Mm.
this I think also another tower have flame and some smoking.
Yes, yes.
Yeah,
Yes, I think
I don't know
mm.
if I'm correct, but I see like this in my city. Also for
Oh,
yeah, also for
mm.
oil.
Oh, I think that's one of the reason when we talk about the tower, the one that we discussed just now, right? So the tower, so usually when it has a lower, much more lower boiling point, so sometimes we collect it in the vapor or gas form, right? So sometimes it may contributed to the pollution. Okay, so we have another one, which is vacuum distillation. It's a very brief introduction about the vacuum distillation. And we have another one, which is steam distillation. But for the steam distillation, so like you can go through in the Putra Blast. So don't forget to key in your attendance for today. So in the Putra Blast, I put several manuscript or journals related to the steam distillation. So one type of the distillation that widely used, for example, currently, for example, in the extraction of the essential oil, right? For example, you want to take the oil from the lemon, for example. So steam distillation is the best method that you can use, for example. So I hope that you can go through the manuscript, the article, okay, and then you can have one page of summarization. What you can get from the steam distillation? What are the difference between steam distillation as compared to the one that we already discussed? Okay, so for that kind of the assignment, I think it's quite very simple assignment. You can have your time. So if your we call it as a summarization is ready, so you can just upload it in the Putra Blast. Okay. Okay, so before we stop, I think because I have planned that we can finish this one before the buka puasa, before the Maghrib for us, a Muslim. And then another 1 hour, which is after the prayer, after the breaking fast, which is 8 to 9, you can have the time for your assignment, okay? To discuss about to read about the article that I uploaded in the Putra Blast, okay? Okay, so before we end the class, so I will go through a little bit on the vacuum, just only a few slides, I think 5 slides, because just to introduce what is the difference about the vacuum distillation, why we need this kind of the distillation as compared to the fractional and also simple. Okay, another important information when we talk about the vacuum distillation, the first one is when you have some compound that have high boiling point. Okay, so usually it more than, for example, if you have the boiling point is 150 degree, and then you know that when we apply it in the simple distillation, of course, we can use it. Sometimes it's very unstable to heat. Unstable mean it can, we call it as a decompose the compound itself, okay? Because in the distillation, we want to avoid any chemical interaction, any chemical changes happen to the molecule. Okay, so for example, if you have one substance that have high boiling point, okay, so to boil such compound, it's better to lower the pressure at which such compound are boiled instead of increasing the temperature. So what does it mean? Okay, so you have one substance and then this substance have high boiling point. So instead of you are follow directly the boiling point to proceed with the distillation, so how about we introduce the vacuum into the distillation process, okay? So we add the vacuum, for example, when we add the vacuum or we supply the vacuum into the apparatus, so automatically in the setup, so the pressure in the system become lower. Lower than the atmospheric pressure, right? So you know that atmospheric pressure, for example, is 1 atm, right? Or we call it as a 760 torr. So when we apply the vacuum into the distillation process, distillation setup, so the pressure will be much more lower as compared to the atmospheric. Okay, so why this is important? Because once the pressure in the distillation process is lower, so automatically it will decrease the boiling point of the compound. Okay, so we try to relate back with the basic chemistry lah. For example, you have a pressure, it apply it, so the boiling point of the compound will be lower. Okay, so from that we can proceed with the distillation. Even though we cannot follow the exact boiling point that the substance have by applying the vacuum into the setup, so we adjust the pressure in the system, so it will decrease the boiling point of the compound. Okay, so once the pressure is lower to the vapor pressure of the compound, so this is the meaning, okay, the rest of the distillation process can commence, and this technique we call it as a vacuum distillation. Okay, so in another word, so easy for you to understand, for example, because liquid boil at lower temperature, so you know that when we talk about the simple distillation, fractional distillation, so usually we are dealing with the one that have lower boiling point because it's easy to vaporize. Okay, so vacuum distillation is used to distill high boiling liquid that would decompose at their normal boiling point. So it's easy for you why we need to choose the vacuum distillation, because we are dealing with the substance that have a higher boiling point. When it has higher boiling point, sometimes when we try to distill using a normal or simple distillation, so usually it will be easily decomposed. Okay. Okay, so how it works? So basically, it's quite similar to the fractional distillation, but instead of we run it under the atmospheric pressure. So usually we have to supply one, we call it as a setup, or we call it as a vacuum into the system. So the vacuum can be vacuum pump, okay, or we call it as a aspirator. So it can be aspirator, it can be vacuum pump, as long as we know that the vacuum, okay, will be supplied into the system. Okay, so once it's applied into the system, automatically it will decrease the vapor pressure, lower as compared to the atmospheric pressure. So it will decrease the boiling point of the substance that we want to separate. Okay. Okay, so why we are choosing vacuum distillation? So of course, faster processing time. When we talk about the faster processing time, mean faster processing time when we are dealing with the substance that have a high boiling point. Okay, so if we want to use a simple distillation or using atmospheric, in the industrial we call it as an atmospheric distillation unit or vacuum distillation unit, right? So you can see that in the internet, for example, you find that VDU, ADU. So what does it mean? So VDU mean vacuum distillation unit. This one is atmospheric distillation unit. Atmospheric mean the distillation is undergoing under atmospheric pressure. Okay, so if effective distillation, okay, while keeping the process under the maximum temperature of the distillation unit heater. So because of course, even though we can adjust the temperature, for example, we can keep supplying the heat. So one of them may be the substance can decompose, and another one is to protect the overheating happen in the system. Okay, so if we allow the heating process happen too much, right? Okay, so effective process of higher boiling point solvent. So this is the one that we already discussed, without ignite them or causing thermal breakdown, or the compound will remain as it is. It didn't decompose, right? Why? Because we try to lower down its temperature or boiling point, sorry, by applying the vacuum. Okay, so vacuum distillation is used to liquid to be distilled that have high atmospheric boiling point. Okay, of course. The second one is liquid that chemically change, okay, at the temperature near the atmospheric boiling point. So like I already mentioned, it can decompose, right? It's not thermally stable, right? So to remove solvent from the mixture without damaging the product. So in another word, when we talk about the vacuum distillation, we want to avoid any damage, or we call it as a chemically change happen of the substance if we keep using, okay, if we allow it to boil with its atmospheric boiling point, okay. Okay, so when we talk about the laboratory scale application of vacuum distillation, I think this is the one that Zahia said previously, right? Which is the rotary evaporation or rotary evaporator. Okay, so this is the rotary evaporator. So as we can see here, so from here, you know that this is spin steaming hose. Spin steaming hose here, steam is the one that we applying the vacuum into the system. Okay, and then we keep rotate. So that's why the name is rotary, because it keep rotating the flask, right? Okay, and then heating water bath here. Heating water bath usually because we want to avoid, for example, if we have the very small, we call it as a boiling point. So when we use direct heat, for example, so the process happen too rapid lah. Okay, we want to control on that part. Okay, so the most important one when we talk about the rotary evaporatory, do you have any experience in handling this one, for example, in the lab? Because it's quite common, right? So do you have any experience, for example? Maybe currently you are doing some, for example, process that separating the solvent, bulky solvent, for example, in the lab. Okay, so usually this is the one that we use. We try to supply the vacuum if we are using the substance. We want to separate the substance that have a high boiling point. Okay. So basically, when we talk about the rotary evaporation or rotary evaporator, this is the laboratory scale. Okay, so even though it's a laboratory scale, but it's widely used, right? For example, in many application, when we try to separate the, like you mentioned, the bulky solvent from its mixture. Okay, so the rotary evaporator rotate the distillation flask to enhance the distillation. So sometimes we curious why the rotation happen. So basically the rotation happen to substitute to substitute the function of the, for example, sometimes if we are using a flask and then we try to put it in the hot plate, so we put the magnetic stirrer, right, into the solution. Why? Because we want to make sure that the solution or the mixture always try to stir. Because we want to increase the distillation process. When we talk about the rotary evaporation, so because it's keep rotate, so the function is quite similar. Okay, so they're rotating the flask throughout liquid on the walls of the flask and thus increase the surface area of the evaporation. So it will allow more liquid to form to do the vaporization, to escape from the liquid surface, right? Okay, so heat often applied to the rotating. So of course, because we talk about the distillation, because we always introduce the heat, and the most important one when we are dealing with the one that have a higher boiling point, so usually vacuum will be introduced into the system. Okay, so when we talk about the rotary evaporation, not necessary to introduce the we call it as the vacuum, because we can adjust based on this one. So this is the one that we can adjust. Okay. Okay, so how about the industrial scale or industrial application? Where we talk about the fractional distillation, so we always talk about the crude oil separation, right? We want to separate the many hydrocarbon from the crude oil to come up with the beneficial product, for example. How about the vacuum distillation? So we are focusing toward the oil refineries. Okay, so as we can see here, so this is one of the vacuum distillation unit, but you have to bear in your mind where we talk about the oil refinery process, vacuum distillation unit is one of part lah. So that means it's not contribute to 100% to refine the oil, but it will contribute part of the process. Okay, so vacuum distillation is a part of the refining process, help to produce petroleum product, for example. Okay, out of the heavier oil leftovers. So that means, for example, after you are doing any distillation, after the system do, for example, here we have a simple distillation, maybe fractional distillation, and then it undergoing under the atmospheric distillation unit. Okay, but still we cannot separate the heavier oil. Okay, so what you have to do, so you have to apply it in the vacuum distillation unit. Okay, So the end of the product of atmospheric distillation called bottom, because you know that the one that stuck in the bottom, the one that have a higher boiling point, right? Okay, so remain at the bottom of the atmospheric distillation unit. So from here, proceed with the vacuum distillation unit. So to increase the production of high value petroleum products, so these bottom are run through a vacuum distillation to further refine them. Okay, so that's why I said that when we talk about the oil refinery, vacuum distillation is part of it. Okay. Okay, so I think that's all for the vacuum distillation. So I hope that you have an idea, right? So sorry. Yes, stop share. So stop.